Well, energetic students, welcome to this series of PYQ Power Play. The NSEP exam is just around the corner, and this is the time that you should be solving as many PYQs as possible. So, in the second part of this series, we are going to solve next four questions of 2023 paper. And again, as we always believe in quality over quantity, we're not going to solve a lot of questions. We'll solve four questions today, and I'll have more of these episodes coming in where we'll be solving 4 to 5 questions each time. Now, my name is Bhavdeep Sethi, and I have been converting a lot of physics haters into physics lovers. And I always say, never memorize physics. Physics is all around you in the nature. Learn physics with the nature and conceptually, never memorize. And that way, you are going to become a physics lover. Now, what should you not expect from this session? Just one thing, which is spoon feeding. Now, if you're here thinking that I'll be presenting the question to you and giving you all the steps to solve it, no, that's not going to happen because that's spoon feeding. And there's enough material on internet. If you want all the steps, you can go to internet and you can look for those solutions there. What we are going to do today is we are going to look at a question. We are going to think logically. We are going to analyze it together, come up with problem solving here. We are developing our problem solving skill. So I may solve the entire question, I may not solve the entire question. The idea is to make you think and learn to think. So first things first, the exam date is 24th of November, 8:30 a.m. Now we have covered all these in the previous episode. So if you want to enroll, this is the time because August 21 to September 14 is when you can register. Now there are on Vedantu Olympiad School YouTube channel, there are videos made by a lot of us. Nidhi ma'am has made a very beautiful video out there where she shows how you can fill this form step by step. So she will walk you through, click here, click there. What if the school is not listed? Your school is not there. Do not panic. You she will guide you through the journey. What if your city or district is not listed? What should you do? So go through Nidhi ma'am's video on that, and that's going to cover the entire process here. Now, again, talking about the eligibility, I have made videos on those, and this is the simplified version. If you're in grade 8th and 9th, rather prepare for NSEJS because that's what you're eligible for. Nidhi ma'am classes are going to prepare you for those. If you're in 10th, 11th, 12th, then again, all this date of birth criteria, I have made video on that. You are eligible for NSEP exam. Pattern is 60 questions, 216 marks, and it's not just about solving question, it's more about your time management skills as well. So let's jump into the first question here without wasting any more time. So a bullet is fired vertically up with half the escape speed from the surface of the earth. The maximum altitude reached by it is, ignore the effect of rotation of earth in terms of radius and all that. Now, one thing is when students come across these questions, first thing they're thinking, oh, what is the formula for escape velocity? What is like no, nothing, no formula needed, just common sense. From first principles we are going to do. So think about it. Let's say I have this planet Earth. So let's beautiful Earth here, right? Now let's say there is some bullet here, some ball here, some pen here, and I want to throw it to infinity. What would happen now is this has potential energy here, and then you're giving some kinetic energy. When it reaches infinity, let's say I want to just take it to infinity and it can stop there. So I'm saying, okay, let the kinetic energy be zero there. By definition, potential energy is zero there. So the total energy should be zero there. So if the total energy has to be zero there, it has to be zero here. It cannot be negative because potential energy is negative. I want to give as much kinetic energy to make it zero so that total energy is zero there. That tells me how much is the escape speed to start with. So you can say to start with minus g, m is the mass of the earth times mass of the bullet or whatever object divided by the radius. That's the negative potential energy here. And I would give it some energy, which is half mv square, that v I do not know, in such a way that this thing plus this thing should be equal to zero, because if it is zero here, it will take it to the infinity point. Now you can solve this, cross out these m's, and then rearrange all this. What you're going to get is this implies the escape velocity. Escape velocity is how much velocity would take it to infinity. That is coming out to be square root of 2 gm by r. I mean, what I'm trying to show you is there is nothing to memorize. We just did conservation of energy here. So we are saying, okay, what is the escape velocity? This is the escape velocity. Now the question says, okay, that may be the escape velocity, but we are not giving that much of velocity. We are giving half the velocity. If you throw this with escape velocity, it reaches infinity. But what if I throw it with half the velocity? Where would it reach? We'll do the same thing. We'll say, okay, when it started here, it has this gmm over r of potential energy, right? That's where, right? That was the potential energy of this object. And how much kinetic energy I'm giving? I'm giving half times mass times velocity square. If this were the velocity, which is escape velocity, I'm giving half of this. And if I square this square root is gone, but that half becomes 1/4. So multiply by 1/4 of 2 gm by r. See what I'm doing here is this is the potential energy here. I give this much of kinetic energy. Where does it reach? So let's say it reaches some point here, and that point is, let's say, h distance from the surface of the earth. So I'm saying, okay, where does it reach? How far does it reach? Okay, when it reaches there, it has zero kinetic energy because it stops, but then it has some potential energy, that would be negative of gmm by the distance from the center, right? So that should be equal to minus g mm over distance from the center would be r plus h, because this h is from the surface of the earth. I need the total distance to plug it in there. And that's all you solve. So you start simplifying. You can say, okay, this g crosses out everywhere. G crosses out, then both cross out, maybe, yeah, both cross out, so both the masses cross out. Then what I can cross out here is 2 crosses out. Wow, it becomes such an easy equation to deal with. So I have negative 1 by r plus 1 by 4r, that's what I'm looking at. 1 by 4r is equal to 1 by r plus h. Now this is a simple equation to solve, and you will get r by 3. So you will get h is equal to r by 3. That's where it will land. I mean, it will go there and stop there, and eventually it will come back. Assuming there are no heavenly bodies around, it's going to come back. Next question, very beautiful question again. A can is a hollow cylinder. It's a cylinder, hollow cylinder. Obviously, it's a can, something to fill in there, of radius r and height h. Its ends are sealed with the circular thing of the same material. The can is made of thin sheet of metal of areal mass density. What is areal mass density? Density is mass by volume, kilograms per cubic meter. But let's say you have a sheet. You can say kilograms per square meter, as in every square meter or every square centimeter has how much of mass. So that's given as sigma. So how much will be the mass? Mass will be area multiplied by this sigma. The moment of inertia of this closed can about its vertical axis of symmetry. This is a very simple question. I don't know why this appeared in this exam, but it's very simple. So moment of inertia about this axis, this will be a solid disk plus this solid disk. So these two solid disks. Okay. Huh. How do I close this now? Okay. So this solid disk and this solid disk, right? And then this hollow kind of shell out there. So this is a cylindrical thingy, but that can be visualized as a ring. Isn't that a ring? So the total moment of inertia will be the moment of inertia of this disk, and this ring. So let's calculate for this one. So how much is the area? So how much is moment of inertia? Moment of inertia of this will be mr square by 2. So how much is the mass? Mass would be area, which is pi r square. That's the area times sigma. Isn't this the mass of this disk? Because sigma kilograms per square meter, these many square meters is what I'm talking about. So this is m times the radius square, times radius square. So this is the moment of inertia, sorry, divided by 2. So mr square by 2. So that is the moment of inertia of this. But then this contributes equally. So I'll say, okay, everything multiplied by 2 because area times sigma, if this is the mass of this, times r square by 2 is the moment of inertia of this, but then this also contributes equal. So this is the total moment of inertia of these two. Then goes on for this hollow thing, the mass of that would be the curved surface area here, which is 2 pi RH. So 2 pi RH is the area times sigma, that's the mass of this, but the moment of inertia of the ring would be mr square. So this there plus r square. And then you factor out things. But before that, I would like to cross out this too. So what all can you factor out? Pi can come out. Yes, very good. R to the power 4, R cube. So I can take out R cube out. Good. Sigma comes out. Good, good, good. So what's left inside is 1R plus 2H. So whatever option matches here, I don't know. With this one, option number C. So option number C is your right choice. See how easily these questions can be done. And again, NSEP exam is not just about solving the question correctly, it's also about solving it within the time frame. You have to plan because if you spend too much of time on these simple questions, you will be losing time or falling short of time in the challenging questions. Now, a particle, oh wow, this one is one of my favorite questions. Very interesting, very interesting. A particle of mass m is revolving in a horizontal circle on a frictionless horizontal table. So there's no friction on this table. With the help of a string tied to it passing through the hole at the center of the table. So they have dig a hole there and there is a thread going down. So think about it. These two masses are trying to pull this down, and that creates a tension in the string, and that tension in the string is giving the centripetal force. Now they're saying, what if, okay, everything was moving, there's no friction, nothing, it keeps on going forever. What if you gently remove this one of these masses? So the question is, what if you gently remove these one of these masses? What happens to the radius of rotation? Now, one thing is for sure that if you're reducing this mass, the tension reduces. So obviously this is going to take a longer circle. So radius has to increase. So these two options don't make sense to me. Don't make sense as in they are definitely out. Right. If three were out, then I'm done. But unfortunately only two are out. So these two are out. We are still left with these two choices. Now if you're going to go for guesswork, at least you're better than choosing one out of four. It's one out of two now. But I would not recommend doing guesswork. It's not required first of all. No, the point here is, as I said, I'm not just going to solve the question here. I'm going to tell you how to think about problem solving skills. Now, point is, of what is my approach here? Am I conserving energy? Am I conserving momentum? What's going on here? See, the thing is, energy cannot be conserved, obviously, because there's a gravity involved here. Gravity will be doing some work and all that. So energy conservation doesn't work here. So what about momentum? And it's rotating, so angular momentum. So we know momentum will be conserved when there is no torque, right? So the momentum will remain the same as long as there is no torque about this axis. Now, what are the forces? There's a tension force here, it's going through the center, there's no torque. And this is not providing any torque, it's going through the center. But then there's a force going down, mg, and there's a force going up. So there are two forces here. They might have a torque above this. But think about it, it's on the level surface and it's not going up and down. So this one and this one, they're exactly equal. So whatever torque is in the clockwise direction is in the anti-clockwise direction. So you have to start thinking in this manner. So there is no torque as such, even though this is providing a torque that is balancing out. So if there is no torque, there is no change in angular momentum. So what is angular momentum here? It's mass times velocity times the radius. So can I say if the radius increases, m times the new velocity times new radius has to remain the same. So there comes our equation where I can say mass times the initial velocity times the initial radius of rotation should remain equal to mass times new velocity times new radius of new radius of rotation. And this gives me masses would cross out. This gives me V1 by V2. This gives me V1 by V2 is equal to R2 by R1. So that's my starting kind of thought process here. So I know some relationship between the original and new radii, but then I don't know any relationship between velocity. So what do? I can think, okay, these two masses were providing centripetal forces. So mv squared by r, think that way. So currently there is 2 mg. So can I say 2 mg was providing centripetal acceleration of mv square. So m v1 square by r1. Can I say that? So this 2 mg is providing mv squared by r, original velocity squared by original radius of curvature. Now, when you gently remove this, the tension or the centripetal force becomes mg. So I can say now mg is equal to mass times the new velocity square v2 square by r1 or r2 rather, right? So these are my relationships for those. And again, I can find another relationship between V1 and R1 and V2 and R2. You can see if I divide these, all these MGs, M, everything crosses out. I'm left with V1, V2, R1, R2. And then there's another relationship and I can solve those. So let's proceed. I mean, though I don't want to do that, but I'm tempted to do that right now. So if you divide this mg crosses out, this 2 crosses out, what you're getting here is 2 is equal to, so let's solve it, 2 is equal to v1 by v2 whole square. So v1 by v2 whole square multiplied by r2 by r1. R2 by r1, see R2 by r1, isn't it? So r2 will jump up, not there from here. So r2 jumps up, r1 comes down. Now they're saying what is the relationship between the new radius and the old radius? So if I can remove this V1 by V2, if I eliminate this, I have the relationship between R2 and R1. I can do that because V1 by V2 is R2 by R1. So R2 by R1 whole square, R2 by R1. So that's R2 by R1 cubed. So let's write it here. So 2 is equal to R2 by R1 cubed. And then you take the cube root on both sides. So cube root of 2 is equal to R2 by R1. So that means R2 is this many times of R1, and that is definitely close to this number 1.260. That's your answer. Okay. And how do I know that? Basically, I don't memorize cube roots. Square root of 2 is 1.414. It has to be a number between 1 and 1.414. So it has to be greater than 1, less than this. And that's the only right choice over here. And obviously, it was not square root of 2. So that choice is very clear. The next question here is 3 star. Wow. Very beautiful question. Very beautiful question. So what it is saying is there are 3 stars of equal masses and they rotate in a circular path of radius r about their center of mass. So it's a mutual kind of gravitational force. They're moving together like a twin star. This is a 3-star pattern. So let's start making the diagram here. So the diagram is, okay, they are mutually attracted towards each other and that's giving the centripetal force. So I know by symmetry here, what would be happening is there is, and see, let's say if there is a tool to draw a line or a triangle. So there's a line tool there. So let's say this, and this. So it is going to be an equilateral triangle. That is for sure. I mean, that's very obvious that one star is here, one star is there, and the one star is here, and because of symmetry they'll be making an equilateral triangle. So this is being pulled by this and by this, and that provides a centripetal force to go around that circle. So let's say we draw the circle also with another color maybe. I'm not a very good at freehand drawing, but I think I did awesome job over there. So yeah. Now let's say they are rotating about this center. This is the center, right? That's center. Now you know this is equilateral triangle, and I know by symmetry this angle is going to be 30 degrees, and that is also 30 degrees. So whatever force this is providing, same force this is providing, the cos of those two, like cos 30 of those two, is providing the centripetal force. So let's write down some things here. So let's say this is my variable of radius. So they're saying we have to find the common speed, obviously. We have to find omega. Now radius is r. Now if you go by simple trigonometry, if you go r, and this is cos of 30 is root 3 by 2, so you know this much of length, then you double that, that is root 3r. So this whole thing is root 3r. Now this is coming from very elementary trigonometry. There's nothing big in there. So you're using cos theta, so this becomes root 3 of r. So now this force, how much is this force? This force is G times, assuming the mass are mm, so m of this mass times this mass, gmm, times the distance square. So root 3r square is 3r square, 3r square. That's this force times the cos theta, because I need this component of the force. So cos 30 is root 3 by 2. Good, root 3 by 2. So that's the force component because of this star. But then this star is also pulling, and together those two forces are providing centripetal force to this star. So this multiplied by 2. So all this multiplied by 2. This is the net force that is providing centripetal force. This is equal to mass times omega square, the one that we have to calculate, m omega square times r. So that's the force is equal to mass times centripetal acceleration. And just solve this. This is your answer. So let's say this 2 crosses out with this 2. One of the masses cross out. This root 3 makes this as root 3, and this becomes r cubed, and you take the square root of that. I don't know, one of these. Yeah, this one is matching. Right, gm, then root 3 there, then r cubed, and then square root of that. So that's your answer. See how easy these are, right? So if this was easy, I would really encourage you to promote this video so that I can come up more of these episodes. And I promise I'll be doing a lot of these PYQs because the exam is just around the corner, and I would like to give you as much practice I can. Now, we have also started a full physics mastery course. So obviously the NSEP 2024 exam is just around the corner. But let's say you're in grade 10th or 12th or even 9th, I would say, and you think, okay, this year 10th and 11th graders may be giving NSEP 2024, but next year maybe with a better preparation give it more seriously. And for 9th graders who think, okay, next year I'm going to give it full energy, so this course is for you. We have started this course as a long-term batch where there are a lot of live classes, alternate Sundays test, you get doubt support on Telegram group, a lot of things over here. Now, this is divided into 5 modules. So, module 1, 2, 3 are 11th grade syllabus. Now, students, we have started this batch in the month of July. So, the first module is over. But not to worry, we have covered basic things like motion, relative motion, laws of motion, and friction. I will provide you free recordings of this if you're trying to enroll from this point. So, you can enroll for this. This is going to start on 9th of September. So this will start on 9th of September. You enroll for this, but then you will get a free recording of this. I'll tell you how to enroll also. So you join from here, and I would guarantee that you will be able to cope up with this, provided that you have enough Josh to learn. Then this is module 3, and then you have module 4 and 5, which is all electromagnetism, modern physics. All this is 12th grade ka syllabus. Now, many students ask, what are the prerequisites for this? Do I have to know calculus? Do I have to know trigonometry? There are three prerequisites. One is the willingness to learn. Second is commitment to hard work, and third one is the Josh. So what I mean by this is, maybe you think my concepts are not very clear right now. Should I even think about Olympiads? Yes, provided that you have willingness to do so. You have dedication, determination, Josh. Join over here, and I will ensure that your hard work is going to bear the fruits. Now you also get a 20% discount if you enroll with the links given below, or I can show you here. So if you go to vedantu.com, let's say you go to vedantu.com, you go to courses, then you go to Olympiad here. So click on courses, Olympiad here, you click on that, you get full physics mastery 2025 modules 2, 3, 4, 5, plus it says plus module 1 recording. So you're going to get 4 modules live, but the first one recording is available for free. Click on that, choose your grade 9, 10th, 11. So let's choose 9. Now this shows the price is 10,000 rupees. But as I said, you will get a discount. So if you click on view all offers, done, apply coupon code. So without any gaps, get 20. So there's no space between get and 20. So get 20, click on apply. See, the price comes down to 8,000 rupees, or the link is down there. You can click on that. You will get the discount anyways with that link. Okay. Now, obviously, we have been getting a lot of gold medals, silver medals, and I have spoken a lot of good words about these joshful students who were part of Vedantu Olympiad schools, and we are very proud of them. And one day I would like to see you over here. So yeah, keep up the high Josh, students. I'll come up with more of these PYQ series. Spread out the word. Tell your friends about this series. So keep up the high Josh. Good luck. Bye bye. See you soon.